Question 3 now. This is the equation. You want to pay attention to the units. Time here is in years. Because later on it asks 1 month. You probably have to convert 1 month into year before you can substitute the t value into the expression. But I'm just going to start with defining. A few people ask me what to do if you need to define. So h of t equal to a third. Take care and make sure that there is a multiplication sign between everything. So a third times t times bracket 2 times t minus 10 and then times t minus 10. Okay, if you want to put the domain in right now, you can. You just need to control and then equal, so that will open up this little box and you need to click on the dash. And then we're going to put in the domain between 0, control equal again, less than or equal to t, control equal, less than or equal to 2. So that's if you want to put the restriction in when you define, which is probably the easiest. There's some issues with it sometimes. We'll see. Do we get that? We know how to put the restriction in? You don't always have to do that. Like you can have it without the restriction, as long as you know to consider the restriction when you solve. But that's with the restriction. What is the height of the tree after 2 years? So h of 2, 32 meter. Now if you put, I just put the answer in first, and then I want to talk about one thing. So trying to find h of 2, 32 meter. You have to be careful when you put in the restriction. Let's say, for example, if I made a mistake and actually put, instead of less than or equal to 2, let's say I put less than 2 in my restriction. Can we look up for a second? This is something you have to be careful of if you put a restriction. Let's say this is the restriction that I put in. If I do that, and then I try to find h of 2, it's going to come out as undefined because I have accidentally restricted the graph to not include 2. So if you see something like this, it might have been because you have restricted it incorrectly. All right? So you just have to be careful. And if you're not confident with restriction, you maybe start with no restriction and then work from there. So I need to fix this by putting less than or equal to, and then I have h of 2 is 32 again. So be careful with the restriction. It's going to cut off some values if you get it incorrectly. How fast is the tree growing initially? What does that mean? Yep. So first of all, how fast? How fast is another way of asking for the rate. We're not asking to find the initial height of the tree. We're asking for, they're asking you to find the rate. So how fast is rate? The rate initially is when t equal to 0. So we're trying to find the instantaneous rate of change when t equal to 0, which is another way of asking for h prime of 0. Now this is where the calculator is going to have some issues. So you have to understand what the issues are and play around with it. So this question's a bit weird. All right, I'm going to find, I don't know, let's call it k. So k is the derivative of h. All right, so k of t is that. Now, if you look at the derivative that the calculator got, it actually doesn't exist when t equal to 0. Have we got up to this question? And we're still putting the derivative in. All right, I'll give you a minute. I want to point, yes, 1 minute. I want to point out this really annoying thing that happens whenever you define the derivative. It doesn't include the derivative at an endpoint immediately. Have we got the derivative? Once you have the derivative, try to just type the derivative out, see whether you get something like this. It may not be identical, but it should show up with a domain. Really? No? Okay. Still working on that? Yes? Keep going? So, have we got the derivative? What is the domain of the derivative here? So if I substitute t equal to 0 into the derivative, it will be undefined again. This is because if you put the domain into h, so if this is my definition of h, pay attention. When you define h between 0 and 2 inclusive, because those 2 points are endpoints, the derivative will not exist at those 2 points. So h has values of t at 0 and 2. The derivative is not going to have that. So if you want to find the derivative when t equal to 0, you need to remove this restriction altogether. This is the issue with putting in the domain in the first place. It actually may limit your options because it automatically restrict your derivative function. So maybe don't do it then. Maybe just leave it. And when you need the restriction, put it in afterwards. So if I think I don't need to define this again, but if I write this again, so it just has the derivative. It no longer has any restriction with it, and I can actually find the derivative at t equal to 0. So that's the issue with having a restriction. So h prime, we have 100 on 3. We're going to go with meter per year being the unit. Can we move on to part C? At what rate is the tree growing? So again, we're looking at rate. So we're finding the h prime after 1 month. What is time here? What am I using? What value of t do I substitute into the derivative to find the rate after 1 month? 1 over 12, yeah, exactly. Because the initial unit of time is year, so if after 1 month it has to be 1 over 12 year. So I'm trying to find h prime of 1 over 12. Okay, so k of 1 over 12. Something like that. If the question doesn't say round it correct to whatever, just leave it as exact values. So 2,281 on 72. 2,281 on 72 meter per year. Can we try part? How do you do about part D?
But you see, that's the one. We still write meter per year.
Yes. Because the rate function is using t as per year. If you want to write it as month, it has to be meter per 12 months. If they literally ask you meter per month, you have to divide that answer by 12. So yeah, just leave it as meter per year. Part D is asking you to find t when the tree is growing at a rate of 20 meter per year. So we're trying to find t when the derivative equals to 20. If you need to find t given the function, you solve. So solve, k of t is 20. We're finding t. All right, here's an issue. Do we keep this? Which one do we take? Yeah, I mean you can tell which one's a positive one though, even if you. Yeah, that's right. So which one do you take? Both of them? Yeah, yeah. I mean, a tree can go and then go down and then up again. It has to be the first time. All right, going back to part D, the question itself is a little bit vague, but obviously, I think it makes more sense to estimate the number of months. But if you solve, you end up with these two exact value answers. You probably want to control enter to get to the rounded answer to know which one is positive, which one's negative. I'm going to go with the first one.
What answer do you want to put down there?
Because the question doesn't say, I literally will go with the rounded, the exact value. Yeah. In the actual SAC, if we ask you this question, we'll probably say close to the nearest month or something, which, you can estimate to be 0.7 times 12, and estimate the number of months. Because 0.7 is in the number of years, so 0.7 year, a little bit less than a year. Are you okay, Luke? That's part D. Wow, we spent a period on 2 questions. That's fantastic. Just learn to use a cast as much as possible, because in order to complete the SAC, you're going to need to try to speed up, as much as you can.